Episode, and today we are going to learn how to insert new nodes in the list. So in the last lesson we studied the basic explanations of linked list and how linked list is created. Now we have a basic idea, and then we say that there are two important things to remember, that we need two classes to represent linked list. One should be the node class, and the other one should be the linked list class. And we say that in the linked list class, we are defining all the operations, like how to insert, how to delete, or how to traverse a list. So as you see this list, now we learn how to insert a new node either at the beginning or at the end of this linked list. So when it comes to working with linked list, the first thing that you do is try to visualize the problem, to understand the problem clearly. As soon as you understand the problem, then solving the problem is really easy. For example, here you have this list, and now you want to insert this list at the beginning of this list. Right now you see head is pointing to this node, which is the current node, the first node, and you saw like how to manually make the head point to the first node. We did that here. Like you see, head is pointing to the N1 first node, and then node 2 is pointing to the second node, and the second node is pointing to the third node, and third node it points to null. As you see in the node, its next property is pointing to null by default. So now if you want to insert a new node at the beginning of a list, this means that your new node that you have, that you want to insert at the beginning of the list. So simply you say that your new node has to become the first node. What does that mean? That means this node, instead of referencing to null, it has to point to the first node like this, because currently this is the first node, and we have this, we access the address of the current first node through the head. So here you need to do two things. First, you make your newly created node has to point to the current first node, and the second thing is that you make the head to point to the newly created node like this. See, now head points to the newly created node, and this newly created node points to the current first node. After this time, this one is the first node, as you see in the list, in the graph. So now let's do how we solve this problem writing a code. So for all those kind of operations, we need to add like separate methods in the linked list for any operation that we need for the list. For example, if you want to insert a new node, if you want to delete a node from the list, or if you want to traverse the list, for each operation you can define a method here and solve the problem. So now let's create a problem. Let's create a method to solve this problem of adding a new node at the beginning of the linked list. So public void insert at the beginning, insert at the beginning. So always when you call this method, you pass the value of the newly created node. So you say init value. So the first thing you do is you should have this new node. So create that new node. New node equals new node, and the value is the value that comes from that is passed through this method. Okay, so now you have this new node, like this 49. So uh, like most of the time, try to think of some edge cases also. Right now that you see in this list, like picture and graph, there are already 3 nodes in the list. But sometimes it happens that the list is empty. So if the list is empty, that newly created, that is the first node in the list already, and that is the only node or element in the list. So you say if, and how you check if a list is empty or not? You just check the head of the list. If head is pointing to null, that means the list is empty. So if head equals null, that means the list is empty, and this new node becomes the first node. So head equals to new node. That's it. But if head is not null, that means there are already some nodes in that list. So at that time, you do 2 things. First, you make the newly created node to point to the first node. So you say new node dot next. It points to the current first node. And how do you access the current first node? Using the head. Because right now, it was like this. Head was pointing to the current first node. That means you have the address of this node in the head. So you say new node dot next equals head. And the second thing that you did was you said after this time head has to point to the new node. So see, here you made the new node to point to the first node. And now you say head has to point to the newly created node. Head equals new node. As easy as this. It is how you insert a new node at the beginning of a list. After this time, you don't need to do like this. You don't need to create objects here and then make their next property to reference the next node. You created a method here, and this method takes care of inserting the new node at the beginning of the list. So now that you can insert a new node at the beginning, let's learn how to insert a new node at the end of the list. So here you have one more node. Currently 37, it is the last node. But we want to insert another, we want to add another node at the end of this list. So what does that mean? That means the current last node, instead of pointing to null, it has to point to the newly created node. That's it. See, as soon as you make this connection that the current last node, instead of pointing to null, it has to point to the newly created node. That's it. After this time, it is not the last node. This is the last node. And this one points to null. That's fine. See, it was even much easier. However, how to find the current last node, that is the whole point here. Because in this single linked list, we have direct access only to the head of the list, not to the last node. So the most important thing is to find the last node. That's the important thing. As soon as you find the last node, then easily you can tell your last node that instead of pointing to null, point to the newly created node. So that means you have to traverse the list from the head, come all the way to the last one. As soon as you found the last node, then that is the easy thing. So let's create another method. Public void insert at the end. So of course you need to pass its value. So here also, like, consider some edge cases always. The more you take care of all those edge cases, the more you have a complete program. So sometimes it happens that your list is empty. So if the list is empty, that newly created, that is the first and the last, and that's the only node in the list. That's the only element in the list. So for that reason, you always take care of some edge cases, but that is the most common one. Like, you need to check if the list is empty. You don't need much operation. You just make the head to point to that newly created node, and that way you are inserting a new node. So first, let's have our new node. New node equals new node, pass the value. So now you have your new node here. And first check if the list is empty or not. And how you check if the list is empty? So easy. You check the head. If head is pointing to null, that means the list is empty. If head equals null, then head has to point to this new node. That's it. It is the only node that we have. It is the only element that we have. But if head is not null, that means there are some nodes. So we go to the next part, else. So now the important thing is that we have to start traversing the list from the head, from the first node, and we should walk through all the nodes and come to the last one. So right now let's make it point to null. So how we can do that? We need an iterator to keep track of the nodes that we are checking. So we say node, we create a new iterator just to walk through the list using that. Node current equals to the head. So we start looking towards this list from the head of the list. And now we say as far as while the current.next is not null, we have to continue walking through the list. So right now here, when I said node current equals head, that means I am here. Let me write that current here. So right now when I said node current equals head, that means I'm pointing to this one. And so I'm saying that while current.next is not null, we have to move forward. For example, at this point I check, is current.next null? It says no. So I'm saying that, well, current has to come from here, it has to come here. So I'm saying that current equals current.next, like this. I brought that here. I said current equals current.next. Now I am here. Again, the while continues. Is current.next null? At this point, is current.next null? Again, it is not null. So I'm saying again, it says current equals to current.next. That should come to this one. Again, it comes here and checks. Is current.next null? Again, it is not null. It is this one node. So I'm saying move forward. Current equals current.next. Now current comes here. And at this point, is current.next null? Yes. Current.next is not against null, but it is null. That means we found the current last node. As soon as we found the current last node, we say, well, this last node should not point to null. It has to point to the newly created node. So we come out of the loop and say current.next, instead of pointing to null. Right now it is the current.next, the last node. So we say instead of pointing to null, it has to point to newly created node, like this. And of course, so when you say current.next has to point to the new node, that means it has to point to this, like this. And the new node, of course, it is pointing to null because now it is the last node. See how easy it is. As soon as you could visualize the problem and solve the problem on a piece of paper on any blank space, that means you can write the code for that also. So it was all about how to insert a node at the beginning or at the end of a linked list. In the next lesson, we will work on how to delete a node from the list, or how to print a list, or any operation that we need. We are defining all those methods inside our linked list class. And until the next lesson, have a nice time, everyone.